Hello everyone, I hope you're having a good Thursday. Today we're going to be looking at multiplying mixed numbers by a whole number. So obviously over the last couple of days we've looked at multiplying unit fractions, that is to say fractions that are smaller than 1 by whole numbers. Now we're going to look at some other things. So just to start us off, give yourselves a couple of minutes, even better if you can do it a couple of times, and pause the video to try these 5 questions. Now if you've paused it and come back to it, we'll go through them. The first one, of course, is quite straightforward. We've got 4/5, which is 4 times 1. Next idea, very similar again. We've got 3 times 3, so that's 9, but in this case it's 9 over 4, so 9 quarters. This one here, 6/5 times 2, this one's a bit tricky, but you can do the same thing for the top heavy or improper fraction normally. So 2 times 6 is 12 over 5. Of course, we can then change that to be 1 whole and, sorry, not 1 whole, 12/5, of course, is 2 wholes and 2/5 using the strategy we did yesterday. Same idea here, this is 2 1/4. I'm not going to spend too much time on this because this was the focus of yesterday's lesson. Here we're saying it in words, which might have caught some of you out, but it's the same idea. 3/5, that's just 3/5 multiplied by 3. Well, then that's going to be 9 over 5. And here the product, you might remember, it's a long time ago now we did it, but the product just means multiplying. So 2 quarters and 5, that means we're just doing 2 quarters times 5. Don't forget that 2 quarters is the same as 1/2 times 5 then. And then we, of course, we get 5 halves. You could also have 10 quarters, but it's a good idea to simplify it down and not make them more complicated. So moving on now, another task for you to try here. Have a look at these mixed numbers, see if you can figure out what the problems are. Pause the video, give that a go. And then when you're done, we'll go through them. So the first one here, 3 1/2 times 5. Of course, there's a couple ways you could do this. You could multiply the whole number and then the fraction. But the way I like to do it is to change the whole thing into top heavy fractions. So 3 1/2, that's the same as 7 halves. 7 halves times 5, that would be 35 halves, and of course if we do 35 divided by 2 we're going to get, that's not a very good equal sign, is it? We're going to get 17 1/2, so they're off by 1 whole there. How about this one over here, 2 1/4 times 3? Well, 2 times 3 is 6, 1 times 3 is 3, so this one is completely fine, no problems there. This next one, oh, can we see what's happened here? So 1 times 4 is 4, but then they haven't multiplied the fraction. This is why I like to turn it into a top heavy fraction, because this is a common mistake. Instead, what you can do is you could do 4 times 7 and then change it afterwards, but it's easier if we say 1 7/8, you might remember from yesterday, is 15/8. 15/8 times 4 means we then get a nice and simple 15 times 4. It's just like quarter of an hour times 4 is going to be 60 over 8. And then that means that if we then do that one, we're going to get 7 4/8. And of course, can we simplify 4/8? Yes, we can. The best mathematicians you will know this immediately. 4 is half of 8, so we get 7 1/2. Just divide the top and the bottom by 4, since they're both in the 4 times tables. Looking at this one now, 3 7/10 times 2. Ooh, very interesting. It's going to change it to fifths. Is it wrong though? Not necessarily. Let's have a look. So we're going to have 37 tenths times, 37 tenths times 2. And then if we do that, we're going to get 74 tenths. And right now it looks off, right? Because we've got the 7 and we've got the 4. But actually this is pretty clever. That means that's 7 4 tenths. And 4 tenths, we can half the top and half the bottom. They're both even numbers. So we would get 7 2/5. So in fact, this one is correct. Needs a lot more calculation than the other one though. And how about this one? 2 1/6 times 7. So it's kind of right and it's kind of wrong. You never mix a whole number and an improper fraction like this. You just don't do it. It's not right. But the calculation is right. 2 times 7 is 14 and 1 times 7 is 7. But here you want to change this to be 15 1/6. So that's the way that one is done. Okay, moving on then. Hopefully that makes sense. Pause it and have a look at it if it doesn't. Now this is going to be something I would like you to think, what is a question we could have that goes with these ones? And what's an answer that could go with these ones? So with something like this, if we got 2 and 1/7, you can have something along the lines of, if I've got 2 pizzas and 1/7, it could be something like that. For this one as well, maybe I've got 5 lots of 5 slices of pizza. If the pizzas are, going back to the pizza model, 1/3. Sorry, I've been thrown off. Someone asked me a question. We could have 5 lots of that, and of course we'd say things like this is 5/3. And if we had something like this, the answer would be 6 times 3/4 would be 18/4, which of course we can simplify to be 4 and 2/4. And what's that? 4 and 1/2. Because remember, 2/4, I'll just demonstrate this with a square model. It's actually easy if I do it the other way. So if you say that 1/2 here, that's 1/2, is the same as 2/4. So that's the way that one's done. Hopefully that makes sense. Sorry, I think I'm not doing a very good job of explaining this one. Basically, think up ways that some of this could be the question for, and think up things this could be the answer for. And this is the way. Oh, sorry, my numbers have gone a bit weird here. Let's make this a bit bigger. There we go, that looks better. So this is going back to how we can find, when we do a mixed number times a whole number, how can you do it? So one way is to do the whole number times the whole number, and then the whole number times the fraction, which is a bit like splitting it into 2 and then splitting it into 1/3. Seems obvious, right? But then you'd say that 2 times 2 is 4, and 2 times 1/3 is 2/3. So you get 4 and 2/3. Nice and simple, right? And this works here. What we want to do is we want to avoid coming to problems like this, where we end up with a big number and we end up with an improper fraction. So instead what we can do, and this is the way I prefer to do it because it always works, is to change the 2 and 1/3 into an improper fraction. So in this case we'd say 2 times 3 is 6, plus the 1 is 7, so that's 7/3. And then you say 2 times 7/3, that's going to be 14/3. And 14/3 is the same as, well, 14 divided by 3. Can't do that. Carry the 1, you get a 4, you get a remainder of 2, or in this case 2 divided by 3. 4 and 2/3. There we go. Important to know that in this case you can't simplify these any further because 2 and 3 are not in the same times table, they're only in the 1 times table. But if you had a bigger number, let's say it's something like 10 and 15, they're both in the 5 times table, so you could divide them both down. And that's what it means by cancelling it down to the lowest terms, making it as simple as possible. The numbers in the fraction as small as they will go. Doesn't matter which way around they are. If we got 2 times 2 and 1/3, is it different to 2 1/3 times 2? What do you think? Of course, the answer is no. When it comes to adding or multiplying, you can always move the numbers round. When it comes to dividing and subtraction, you can't. So a good way to remember that is if the number would usually get bigger, you can swap them around. This is called commutativity, which is not a term you need to know, but it's nice to know. And it's the same idea. So if we've got 2 and 1/3, of course, 2 times 2 is still 2. 1/3 times 2 is still 2/3. So you're still going to get 4 and 2/3. Nice and straightforward there, but worth knowing so you don't get thrown off by some weird questions. A little bit like at the beginning, how these questions were written in different ways. Sometimes they'll do that on tests to try and catch you out, but if you're a good mathematician, and I know we've got a lot of good mathematicians in our class, this won't faze you. So here's your task for the day. Nice and straightforward, only 6 questions, but please do write them out. If you're struggling, please draw a model like yesterday. It's not mandatory, but I don't really want people to ask me for help if they haven't at least tried a model, because it really will help you visualize it. Try the 6 of these, write them out, and don't forget to email me the work to the normal address. Good luck.